Hi, welcome to the Pole Shift News, the home of the Maverickstar Observatory. Guys, what a month. It has been hectic. You know, there has been so much going on this month. Trying to finish off the cloud chamber to start with. We now find that we've got to, make a few more improvements. I've ordered another 12 peltiers to finish off the array so we can get that down. The best results I've had so far was just yesterday. I was just showing my partner where we was, because obviously, as you saw, this stuff is all over the desk in the spare room, and the best results I've got so far is -36. I think with a little bit more fine tuning we're going to hit that 40 degrees, -40, and we're going to get then some really good results from that. The other thing we've did this month is now move to the next stage, and that's building muon detectors. We've ordered the detectors. They should be here, I believe, Monday, and then there's a few more things to order. There's quite a shopping list to get these muon detectors built. Various resistors, capacitors, and other components. Some of these things have to be made, and we'll be getting on with that as soon as possible, because as you know, I want to take one of these with me on the 19th of September, so that's really my deadline to get that finished. We've got to order another power pack for the cloud chamber, and we've got to also build another 5 magnetometers. I did have 3. I've sent 2 out to Australia to cover Perth, because we've got a strange anomaly taking place there, as you probably know if you saw the video yesterday. And I think we need about at least another 5 for where I want to put these magnetometers next, and that is, as you know, Brazil, South Africa, and we're going to also put them now in the deepest of the magnetic intensities over Canada. We're going to try and see first of all where the highest magnetic intensity is over Siberia, and if Lithuania is close by, we've got a family over there that we can probably get them to house one of our magnetometers and relay that data back to us. It'll give us an idea of what is taking place over there in that intensity over Siberia. Although we do have our Hong Kong magnetometer, which covers that intensity over that side of the hemisphere as it's lurching towards our magnetometer in Hong Kong. We've also got, as you know, 2 magnetometers in Perth and the Gold Coast. So, busy week, guys, this week. There's still loads of things to do this afternoon for me. But as you know, it's the 17th. And on the 17th we whip out the SD card from the Trimag system, and we also take the SD card out of the Magnetosphere sensor. So I'm going to go over that in a little bit more detail, but before I do, as always, guys, none of this would have been able to happen if it weren't for a few like-minded people that knew what it would take to get the questions answered. And what I mean by that is we could not have answered half the questions that we have already to date if we hadn't have set out building the equipment to answer those questions. We've had the Trimag now running for 2 years. We've had the Magneto sensor running and collecting data for 15 months. And soon we're going to have these muon detectors out in the field collecting data on that. It's going to be interesting to know what sort of radiation is collected with regards to the muons in the high intensity areas around the world. It's also going to be interesting to know what the radiation levels are outside these high intensity areas. So we're going to target both of those with the muon detectors. And with what we've recently discovered in Perth, it's going to give us an indication of how close the high intensity region is moving towards our magnetometers, because now I've got a feeling that the reason why we get 2 microtesla movements throughout the month constantly in the low intensity regions is because the high intensity region is at quite a distance away. I believe if the high intensity region is closer, that fluctuation we get of 2 microteslas is going to get less and less and less. The whole idea of this, guys, is that when we do stick out these magnetometers and these muon detectors, is that we not only get an idea of how fast these high intensity regions are moving, but we're going to also now get an idea as to how much protection you have if you live in the vicinity of one of these high intensity regions. Again, we wouldn't be able to ask these questions if we never answer these questions, sorry, if we never built the equipment. And you know, I like to be proactive, more so than when I started out on YouTube about 7 years ago. And now we are an observatory and we are proactive. We built the equipment, and you know, we've invested a lot of money over the last 3 years developing the TriMag, building the magnetosphere sensor, and then putting these magnetometers out in the field. And now, you know, with the muon detectors, it just means that, you know, not only are we more proactive, but we're able to answer more questions that you want answered, like how fast is the magnetic poles migrating, and what risks do we pose? Well, we're going to answer those questions very shortly, guys, in a matter of another few months when we start collecting data. The good thing about the muon detectors is that when they're out in the field, they will measure the data very quickly, and you know, they also display from the time they've been collecting data on the OLED screens and the amount of detected radiation during that period of time. And the people that have got these in their homes won't have to wait for me to you know, get the SD card processed, the data on it. They'll be able to just look at the screen where they've got these things plugged in, and it will tell them the count of radiation over that period of time, or at least the count of muons over that period of time. And remember, if we're getting a lot of muons, that means we're also getting a lot of inbound galactic cosmic radiation, and the muons are just a byproduct of that cosmic radiation entering our atmosphere and smashing into other particles, creating muons. So if we're reading more muons on the ground, then we're getting a lot more cosmic radiation inbound. And as a result of the grand solar minimum, the last 3 years of poor output by the sun with regards to sunspots, we are now in a time period where the heliosphere shrunk and more radiation is coming into our solar system because of the low output of the sun. On top of that, we already have a depleted magnetosphere strength of around 20%. And you know, when these poles do go into reversal in about 4 to 7 years, as we believe on this at this observatory, what will happen then is the magnetosphere will collapse considerably a lot more, and that will allow more cosmic radiation in. But we should have somewhere on this Earth strong regions of high intensity, hopefully, and with the muon detectors out in the field, we'll be able at that point in time, or closer to that time, know where those safer zones are on our planet. So guys, let's have a look at the TriMag data. So if you click onto the poleshiftnews.com website, you'll come on to the TriMag data. The first chart you'll see on this page is this one, and quite clearly you can see that from 1990 to the current date, you know, we've had over 1,000 miles of migration of the magnetic North Pole, and it shows an indication of acceleration, because prior to that, the 90 years before that, we only had just around about 500 miles or so of migration. So in the last 30 years, the magnetic pole has migrated a lot more. We're not sure whether there's a connection between the migration at this time round of the magnetic poles and the sun going through a low solar output, but coincidentally, you know, we have had a grand solar minimum over the last 3 solar cycles, which is around about 33 years, and in that period of time we've had more migration of the magnetic poles. I'm not sure whether they're connected or not, because there's no evidence that shows that, but I do think it is a coincidence and well worth mentioning. Right, so the latest data on the TriMag, as you can see, we're still seeing the same old movement like we have, which is new, by the way, guys. We shouldn't be complacent about it, but we have been seeing this now consistently for around about 4 to 5 months. And what I'm talking about that is these big shifts where the magnetic North Pole migrates around about 250 to 300 miles in a short period of time of about, you know, a couple of days, and then goes back to its original position, but still steadily migrating towards Siberia. So it's still moving east. It's probably moved in the last 2 years since we've been tracking it around about 3 degrees in total, which is around about 150 or thereabout miles. And tomorrow in the upload, I'll just quickly show you exactly where the magnetic North Pole is on Google Earth, so you get an idea as to, you know, its slow progression. But this can change at any time, just like we saw over the last 30 years on the chart before. We can have an acceleration again. And to be honest, guys, when we're looking at that chart that we was just looking at, it isn't going to take much before that line goes vertical. And I do put it around about a distance off that 40-degree mark, where we believe it'll enter the weak field lines and go through its migration around about 300 miles, 250 to 300 miles. So if this deviation that we're seeing moving westerly was to go easterly, it would easily pop over that 40-degree mark. So just bear that in mind. We are in exciting times at the moment, because only over the last 4 to 5 months we've started to see this activity really start to swing into action. So there's definitely something going on over the region of the magnetic north at the moment, and you know, it's continuously doing that. It's not stopped in its new trend, so there's definitely something taking place, as you can see from the data that we've collected of the previous months. So let's have a little look at the magnetosphere data. And finally, the magnetosphere data. As you can see, it's not fluctuated much more than a couple of microteslas over the last month, and that's been the same case now for the previous 15 months. It's always shifting up and down a little bit, but you know, still maintains around about what it started off with, albeit a little slight change of about 2 microteslas. So it's good to know that our magnetosphere hasn't weakened considerably over the last 15 months. So at least we can answer that question for you guys, and the only reason we can do that is because we built the equipment and we've monitored it for 15 months. So the question was, is the magnetosphere weakening? And the answer is simply not at this current time, or at least over a great deal. It does fluctuate over the month in, month out by about 2 microteslas, but that's it. But that could change in the next 4 to 7 years, especially when our poles do go into these weak field lines. By that time, I believe we will see a slight, if not a greater slight, shift in the overall intensity of the magnetosphere. Just before we leave, I thought we'd have a little look at what the condition of the Earth's jet streams are, and I think it speaks for itself. First of all, look over the Arctic region. Not much definition between the subtropical and polar jet streams. Quick look around the equatorial region. And we'll have a quick peek over the Antarctic region. Massive difference when you compare the Arctic and Antarctic region with regards to jet streams. Remember, we are on a tilt which favours the Antarctic being further slightly away from the sun at this point in time of the year, and therefore it puts the southern hemisphere in its winter. But nevertheless, summer time or winter time, for the last few years now, we've had more dramatic jet stream activity over the southern hemisphere when you compare that with the northern hemisphere, and it could be related quite easily down to the amount of cosmic radiation that is inbound. If we can get our muon detectors as close to the Antarctic region as we can, we might find out some clues as to why the jet streams are in those regions behaving like that. What I mean by that is, if we find that the muon count is off the chart in those regions, then it could stand a chance that it is down to the cosmic ray influx at this moment. But it's going to be interesting, guys, when we do at least get our muon detectors in the region of the jeez, it's always the way, isn't it? There we go. Let's see if we can get it back to a size where we can view something. Yeah, if we can get them in the region of the South Atlantic anomaly, which is the region of our Earth, which is currently receiving the lowest protection from the magnetosphere, then we can get a clue as to what's going on. And to do that, we need to put our magnetometers in Brazil and South Africa, and if we can, somewhere in the region of the Falkland Islands down there. So guys, I'll leave it here. I'll say what I usually do. There's a link down there if you want to support us. We are going through money as though we're burning it at the moment on this, that and the other. You know, we've got 3 projects on the go, and we're trying to build these muon detectors as fast as we can. We've got to build at least another 5 magnetometers to investigate what's going on down in Perth. And we're also you know, ordering parts now for the cloud chamber to finish that off, and you know, hopefully within the next few months we'll have all 3 of those projects that's on the back burner at the moment. Well, not so much the muon detector on the back burner, but at least we'll have 3 of those hopefully completed, and we'll have some of these muon detectors out in the field collecting data for us. So guys, the links are there if you want to support us on Patreon or one-off payments on PayPal. You're more than welcome. It's not mandatory, and you know, you have a great weekend, and catch up with me tomorrow, and I'll show you where the magnetic North Pole is currently, and I'll say what I usually do. Have a great weekend, and bye for now.